So, today we're going to be talking about the standard form of a line. So the equation for standard form, the equation is this here, this ax plus by equals c. And we're going to talk about some rules for a, b, and c to begin with. So standard form looks like ax plus by equals c. All right. So a couple of rules. First, a and b, the coefficients of x and y, a and b both cannot be fractions or decimals, so they cannot be fractions. Yes, a Runnels rule. Well, it's actually a math rule, but we can call it a Runnels rule.
Let me dream.
I'll let you dream, dear. Dream all you want. So we've got a and b cannot be fractions.
Wait, what is ax plus by equals c?
That's the equation for the line. That's like the general equation. Equation. So a and b cannot be fractions. Next rule. A must be positive. A must be positive. If we encounter a time where A is negative, I'm going to show you how to make it positive. We can change anything in math, as long as we change everything in that equation, right? All right, finally, C is a constant. What does it mean for it to be constant? Continuous, okay.
Isn't it when you have like a number and then you have a line above it that's continuous?
Ooh, so that's like irrational, so like a repeating decimal.
Wait, is it always
So
a constant?
that's not the kind of constant I'm looking for.
Is it always a constant?
So it's C is always a constant. Yes. Yes, sir.
C is always the same.
It's always the same. So by that, do you think I mean it's always the same number?
No, it's not.
No. By that I mean no matter what I do, it doesn't change. So what I mean by that is C does not have a variable. So C does not have a letter with it. Okay? Is that okay? So C is always a number. So the term is always a number. So occasionally will we throw in some variables for that constant? Sometimes, yes. But that's for the purposes of problem solving. Okay? So generally it's going to be a number. For our purposes it's going to be a number like 7 or negative 12 or 3.5. All right. Am I moving too fast? Are we okay? We're at a good pace? All right, some benefits of standard form. So yesterday we saw slope-intercept form was really nice because we can find where it begins, and then we can find we just have to count up and over to get to the next point, right? Or down and back, or down and over, or up and back, right? So we could use the slope and the y-intercept to graph the line. Here, the benefits of standard form is it's really easy to find the x and y intercepts. So, oh, sorry, I need my pen. We can find the x and y intercepts. And we've talked about the x and y intercepts a little bit earlier this year with word problems. Remember, the x-intercept can tell you like, well, remember like that bathtub problem we had when it was leaking out water? When we found the x-intercept, that was how long it took for all of the water to drain out, right? Or the y-intercept is where it begins, right? So like the beginning height of the balloon from the test on last, what was it, Tuesday? was gonna say Friday. It was Tuesday. It wasn't that long ago. So finding the x and y intercepts can be useful.
Did you miss those intercepts?
Say it again.
Never mind.
He said, did you misspell intercept?
I might have inters. No, it just my handwriting looks terrible. Sorry, I'm working on it. Intercepts. Intercepts.
With the E?
I
Yes.
didn't see the C.
Sorry.
I didn't see the E, the other E.
There's the C.
Is that better? I apologize. It's a learning curve for me. I'll get it. I'll get it. All right. So I've got a couple of examples for us. So what we're going to do is we're going to go through, and I gave us some problems in slope-intercept form, and we're going to write these in standard form, okay? And then we're going to go back after we've done my examples and then find the intercepts. So I wanted to do one new concept at a time. Is that okay? All right. So we're going to write the equations of the lines in standard form, and later we're going to come back and find the intercepts. So A says y equals negative 2x plus 7. So remember for standard form, I want my x and y to be on the same side. I want a and b to both be whole numbers, and I want a to be positive. So those are the three things I'm looking for. So first, are x and y on the same side? No. So what I want to do is I want to move this negative 2x to the left side over there with y, right? So a positive, the inverse of minus 2x is plus 2x. I'm going to add 2x to both sides. So that gives me positive 2x plus y equals 7. So, now are x and y on the same side? Yes. Are a and b both whole numbers? Yes, so let's talk about a and b real quick. So what is my a value? 2, because that's the coefficient of x. What's my b value? What's in front of y? A 1. Remember, if there's nothing there, it's like it's a 1, right? So my b value is 1, so they're both whole numbers, so that's okay, right? Finally, is my a value positive? Yes. So this is the equation of this line in standard form. That's it. So far, so good? Now, am I going to add a step with each of these? Yeah, I'm going to add a couple of tricks. Well, we got this. I'm going to do it one step at a time. All right. B says y equals 3x minus 4. So first, are x and y on the same side? No, so I want to move that 3x to the left side with the y. So what's the inverse of positive 3x? Minus 3x, perfect. So I'm going to subtract 3x, subtract 3x. So those cancel, so I have negative 3x plus y equals negative 4. Ooh, a is not positive. So x and y are together. A and b are both whole numbers, but x is not positive. I have a negative 3x. I have a negative 3x. So, what do I need to do? We could add and subtract everything, but honestly, that's going to take at least 3 steps, right? Well, I know that a negative times a negative is a what? Positive. And what happens to a number when I multiply by 1? It kind of stays the same, right? So what if I multiplied everything in this equation by negative 1? Would that fix that negative a value?
Yes.
So let's do that. So I'm going to multiply negative 3x by negative 1. I'm going to multiply y by negative 1. And I'm going to multiply negative 4 by negative 1. So what's negative 3x times negative 1? Positive 3x. Beautiful. And then positive y times negative 1 is, well, positive times a negative is a negative, right? Equals, and then negative 1 times negative 4, positive 4. So now, x and y are on the same side. A and b are both whole numbers. A is positive. But wait a minute, my b value is negative. That negative 1 there, so you have negative 1, is that okay? B can be negative, just A cannot. Okay? So that's the equation of that line in standard form. Whoa. Is that okay? So far, so good? All right, let's take a look at C. To A. I'm going to go back to A. We're going to do A together. So let's find the X intercept. And the Y intercept. Do y'all mind if I abbreviate intercept with INT for intercept? Intercept. All right. So remember, when we have an X intercept, that's when the graph crosses the X axis. So what's that Y value?
0.
It's always 0, right? So what we're going to do to find the X intercept is I'm going to plug in 0 for Y. So here I'm going to say 2x plus 0 equals 7. So then, well, that's just 2x equals 7, right? So then to solve for x, what do I do? Not subtract. Divide. Divide by 2. Perfect. So I have x equals 7/2, or I know how much you'll like decimals, so let's do a decimal. 3.5. So my x intercept is 3.50. That's my x intercept. Is that okay?
You put comma?
Yes. 3.5, comma 0, because a coordinate point is your x, comma y, right?
Wait, so what is this called?
The x intercept.
No, like them two together.
Oh, a coordinate point?
No, but like why do you say
It's called the y-intercept and the x-intercept. So to find the y-intercept, I'm going to do the same thing, but what's the x value for all of the y-intercepts? 0. Perfect. So what I'm going to do is I'm going to plug in 0 for my x. So I have 2 times 0 plus y equals 2 times 0 plus y equals 7. So what's 2 times 0? 0. So I have y equals 7. So 7 is my y-intercept. So I have 0, comma 7 for my y-intercept.
Wait, why are we multiplying?
Which one?
Why are we multiplying?
Why are we multiplying? Where? 2 times, well, because that's 2x, right? For the y-intercept, hold on you guys, that's a really good question. She said, why are we multiplying by 0? Right?
Do we always multiply when it's for y?
Well, we would multiply for x also if we had a b value, right? So hold on and I'll do one that has a b value. So we're multiplying. Please don't talk during instruction. So we're multiplying because that's 2 times x, right? 2 times x. So that's why I'm multiplying, but 2 times 0 cancel, well, it's 0. So it's like it wasn't even there. Yes? All right, let's do another one. I want to say B for you guys. Let's do one from the next. All right, C says y equals negative 1/4 x plus 5. Y equals negative 1/4 x plus 5. So if I want to get x and y both on the same side, I have to move that negative 1/4 x to the left. left, yes?
Yeah.
So how am I gonna do that?
Multiply 4.
Multiply? Well, no,
I thought you would.
I don't know.
eventually, yes. Hang on to that idea, but first,
When you add 1/4.
we're gonna add 1/4, thank you. We're gonna do the inverse of minus 1/4 and add 1/4 x to both sides. So my minus 1/4 and my positive 1/4 cancel. So I have 1/4 x plus y equals 5. So x and y are on the same side, but a and b are not both whole numbers, right? So Amy, you said multiply by 4 earlier. Why 4?
Because that. Cause, I don't know. I just said multiply by 4. Because I mean, that's the. Like, I don't know.
No, you're on the right track. Well,
Well, because
Let-
1, I don't know.
what 1/4 is like 1 divided by 4, right?
Yeah.
So the inverse of divide is to
Multiply.
multiply. So if we have a fraction, if we multiply by that denominator, it kind of gets rid of it, right? So let's do that. Let's multiply by that denominator. So can I multiply just the first term by 4? Well, if we do something to an equation, if we do something into one term, we have to do it to all the terms, right? So I'm going to multiply each term by positive 4. So 4 times 1/4 is 1, so I have 1x. 4 times y is 4y, beautiful, equals. And 4 times 5 is 20. So now, x and y are on the same side. A and b are both whole numbers. Is a positive? Yes. So this is my equation in standard form.
Wait, so what if it was like 3 over 4? Would we still multiply by 4?
Yes. We're going to do one of those in just a minute. Very good question. All right, let's take a look at D. Can I scoot over? Is that okay? All right. D says y equals 1/2 x minus 3. So, to get x and y on the same side, what do I want to do with that 1/2 x? Subtract it. So I'm going to subtract 1/2 x from both sides of my equation. So I have negative 1/2 x plus y equals negative 3. So, x and y are on the same side, yes? Yes.
So 8.
Are a and b both whole numbers?
No.
No! So what do I need to do to that negative 1/2 to make it a whole number? Multiply by what?
2.
By 2. So I'm going to multiply each term by 2, just like we did in the last problem, right? So what's 2 times negative 1/2?
Positive.
Oh, a negative times a positive is a negative still, right? So it's negative 1x, right?
Yeah.
And then 2 times y is 2y equals 2 times negative 3, negative 6. Perfect. So now, x and y are on the same side. A and b are both whole numbers, but a is not positive. What do I need to do to make a positive? We could add, but remember that's going to take at least 3 steps. We can multiply everything by 1 because that's going to make, negative 1, because that's going to make a positive, right? So I multiply by negative 1 here, and here, and here. So negative 1 times negative 1 is positive 1, perfect. So I have positive 1x. Negative 1 times positive 2 is negative 2y equals negative 1 times negative 6, positive 6. Perfect. So now, are x and y on the same side? Yes. Are a and b both whole numbers? Yes. Is a positive? Yes. So I have standard form of a line. All right. Quick question before I move on. Here, if I saw I had negative 1/2, could I have multiplied by negative 2 in that first step? Could I have combined those two steps and multiplied by negative 2?
Yes.
Yes. But if you don't see that right away, is the two separate steps too terribly time consuming?
Yes.
It's not terribly time consuming. But Marcus, if you see it, can you combine the two steps and just multiply by negative 2?
Yeah.
Definitely, because we will know we want that to be a positive whole number, right, for our a value. All right, so let's take a look at problem E. Problem E. So I have y equals 2/3 x minus 2. That's like what you were asking about, Miss Amy. What if my fraction has a numerator also? I'm going to answer that question with this problem, if that's all right with you. All right, so if I have y equals 2/3 x minus 2, what do I do to 2/3 x so that x and y are on the same side? Subtract it. So I'm going to subtract 2/3 x from both sides. So I have negative 2/3 x plus y equals negative 2. All right. So x and y are on the same side. Are a and b both whole numbers? No. A is negative 2/3. So that's like negative 2 divided by 3, right? So what's the inverse of dividing by 3? Multiply. So I can multiply each piece by 3 to get rid of that denominator, right? But remember what I was talking about in the last problem? Could I multiply by negative to make that a positive at the same time?
Yeah.
Do y'all want to do that together in this problem? Do y'all want to try doing the two steps together? Is that okay? No? Yes? Okay. So I'm going to multiply each piece by negative 3. Because what's negative 3 times negative 2/3? Positive. Oh, let's see. So negative 3 times negative 2 is what?
Wait, what?
Negative 3 times negative 2? Negative 3 times negative 2? Is positive 6 divided by 3? 6 divided by 3 is 2. So I have positive 2x, right? Then negative 3 times y minus 3y equals, and then negative 3 times negative 2. Oh, a negative times a negative is a positive. Positive 6. All right, so now I have x and y are on the same side. Yes? Are a and b both whole numbers? A is 2, b is negative 3. And is a positive? Yes, so I have my equation. All right, I want you to try F. I'm going to give you about 3 minutes. I want you to try F and check with your group. Then we're going to check it together. Oh, I didn't freeze the screen. I apologize. There we go. Y would still be positive.
Plus y
Yes, sir. Equals 4. Because negative 5 halves plus 5 halves cancels. Oh, that's a 9? Sorry, yes. 9. No, sorry. Sorry, 9. There you go. And then you don't want 5 halves, right? Multiply everything by what?
2.
By 2. You got it. Right. Yes, dear.
I'm trying to get rid of 5 2 plus 5 2 on each side.
Yes, sir.
Which would leave me with 5 2 for y plus 5/2
X, don't forget your X.
x
Equals.
x plus 9.
No, because the X goes with the 5 halves. So you're left with just 9. There you go.
So now I get rid of 5/2.
So how do you get rid of that denominator 2?
Minus 2.
Not minus. So the denominator is like dividing, right?
Yeah, no, divide on each side.
No, it is divide. So what's the inverse of divide? Multiply. So multiply every piece by 2. There you go. All right, you guys, about 30 more seconds. About 30 more seconds, and we're going to review this one together. Review. Yes.
We're done. Is this wrong?
I don't believe so.
Oh, I just said I believe so.
I don't believe you're wrong. Yes. I do believe you're right.
Wrong?
Right. Right.
Miss, I went in the wrong time to find that.
2 times 5 is 10. 10 divided by 2 is
5?
5. So 5x. That's your answer. Don't forget your x. There you go. You're welcome. All right, you guys, let's check. I'm seeing lots of really good right answers. But I see a couple of people are stuck, lost, or asleep. Yes?
Yep.
All right, let's wake it up and do F. So F says, there we go. F says y equals negative 5 halves x plus 9. So, put it away. Put it away. Zip it up. I'm waiting for you. Thank you. All right. So to move that negative 5 halves x to the left side with y, what do I need to do? What's the inverse? Well, we are subtracting, right? Because it's negative 5 halves x. So the inverse is to add. So I'm going to add 5 halves x to both sides. And I know 5 halves sounds kind of funny to some of us, so I heard a lot of 5/2. That's perfectly fine to say it that way. 5/2 is also acceptable. So I have 5/2x plus y equals, there we go, 9. So now x and y are together, but a and b are not whole numbers, so what do I need to do? Multiply by 2, because 5 halves, that's like 5 divided by 2. So the inverse of divide is to multiply. So if I multiply everything by 2, so 5/2 times 2 is 5, so I have 5x, plus 2 times y is 2y, equals 18. So now are x and y both whole numbers, and are a and b both whole numbers, and a is positive? Yes.
Bam. We're done.
Bam. No, remember I said we were going to find our intercepts too. Our intercepts. But why? Because it's fun. Oh. All right. So, I gave you guys 6 problems in slope-intercept form. We rewrote them in standard form, right? So now what I would like for us to do is to find the intercepts. We're going to find all of our intercepts. You ready? The great thing about standard form, Miss Robin, is it actually makes it really fast to find both intercepts. You ready?
They're already there.
Some of them are. Some of them you just got to look with your eyeballs. You're like, oh, look. One that's 0, the other one's this. Done. Some, it's 2 steps, you gotta plug it in and then divide, but you know. Let's see. I'm gonna go back. So which one did y'all wanna do? Do y'all wanna do C, D, E, or F? E? Alright, let's do E. Let's find the x-intercept and the y-intercept. X-intercept, y-intercept. So for the x-intercept, I'm going to plug 0 in for what? For the x-intercept, 0 is y. So I'm going to say 2x minus 3 times 0 equals 6. So 2x, because 3 times 0 is 0, so that part, it's like that piece cancels, right? So we have 2x equals 6. So I divide by 2, so x equals 3. So my x-intercept is 3, 0. Three, 0. Is that okay? My y-intercept. So I'm going to have 2 times 0, because we're going to plug it 0 in for x for the y-intercept, minus 3y equals 6. So that gives me negative 3y equals 6. Fix that equal sign. Much better. So then to get y by itself, what do I need to do? Divide by negative 3. So then I get y equals negative 2. So my y-intercept is 0, negative 2. All right, so that leaves you with F, B, C, and D. I want you to find the x and y-intercepts for those 4 problems for me. I want you to use this method to find the x and y-intercepts for those 4 problems for me. Check with your group. I'm going to come around and check your work.